Hey, we have here another integral. This one's from UNSW 2022, problem 5. We have an integral from 0 to 1, x minus 3 to the x, all squared dx. Thought this was a little unusual to mix just like the x with the x and the exponential like that. And I'm not really that comfortable with it in this form here, so what I did to start was I just multiplied this out, just to expand it out so that we can integrate this separately. So we'll get x squared plus, now if we square this term, we'll get 3x squared, like we'll have 3x squared, but when by exponent rules we can rewrite this as 9 to the x. And then for the middle terms we're going to have minus 2 times x 3 to the x dx. And then I'm going to go ahead and integrate, and we can do these kind of separately. So this first one is clearly, this is just power rule in the first one, so this is going to be x cubed over 3 evaluated from 0 to 1. Now for this, for a 9, to integrate this, I mean, you can remember a formula, of course, but I can write my 9 as e to the ln 9. Okay, then if we're integrating e ln 9, if we integrate this, we're just going to have e ln 9, but we have to take that constant part out and have it in the denominator, so we're going to have an ln 9 here. But this, again, I can write this back as 9 over x, so we'll write this as 9 over x ln 9 0 to 1. We'll come back to this later, but I'm just going to evaluate this part to get out of the way because this part's easy. So plugging a 1 in here, we're going to have 1 over 3. Plugging a 0 and we get 0. We'll skip that part. Plugging a 1 in here, we're going to have, this is just going to be 9 over ln 9. Plugging 0 in, 9 to the 0 is 1. So we're going to have a minus 1 over ln 9. But then we already have a common denominator, so 9 minus 1 over ln 9 is going to be just plus 8 over ln 9. And then before I move on with this part, I'm just going to take ln 9 as a perfect square. So I can write ln 9 as ln 3 to the 2 and bring the 2 out front. Okay, so what we have, I can write this as 8 over 2 ln 3, but then this is the same thing as 4 over ln 3. So what I'm going to do is just write part of our answer up here so I don't forget about it. So we just have our 1/3 plus 4 over ln 3 plus this part that I'm going to deal with next. Okay, so now moving on to this integral, we're just going to evaluate that, and that's going to be our final piece that we need right here. And of course, it's not too bad, but I just thought we'd do this separately because we're going to need, what I'm going to do is we'll use, what I'm going to do for this part is use integration by parts, and I'm going to use the DI methods. We'll use our table for tabular integration. And I'm going to choose my minus 2x to differentiate. That's because when we differentiate it, the degree goes down, it's going to go down to 0. So I like that as for our derivative. And then we'll integrate the other part, which is 3 over x. But now keep in mind 3 over x, what we'll use, like we did before with the 9, I'll write this using the same thing. We'll write it as e ln 3x. When we integrate this, it's going to be just like with the 9, we'll have the ln 3 in the denominator. And then I'm going to integrate this one more time. And what's going to happen is we're going to get another ln 3 in the denominator. So we're going to have ln 3 all squared. And we'll have this e ln 3x here. Now taking the derivative of minus 2, we're going to get just a minus 2. Derivative of minus 2, 0. So then this whole thing, normally the last row is an integral, but because we have a 0, we're integrating 0. So we're not worried about that. We're just worried about taking our solution on the diagonals. So let's write this all out. We're going to have minus 2x. I'm going to put this back, e ln 3x. I'm going to put this back like 3 to the x over ln 3. Then this piece we have minus times minus. This is going to be a plus. So now we're adding 2. Again, we'll change this back to 3 over x. But now we have an ln 3 all squared. Okay, now we just need to evaluate carefully with everything going on. So we plug a 1 in. I'm going to have minus 2 times 3 here. Okay, because 3 to the 1 is just 3 over ln 3. And then here, again, 2 times 3. I'm going to just write that one as 6. I probably should have done it over there. And then we'll have ln 3 squared here. Now, next when we evaluate 0, well, we have this x term, so we plug a 0 in here. This first piece is going to be 0. So we just need to worry about this second one. We plug a 0 in for 3, we get a 1. So we're just going to have our 2 over ln 3 squared. Okay, just a little simplification. So we're going to have, this is going to be minus 6 ln 3. And then we have the same denominator here. So 6 minus 2 we're gonna have plus 4 ln 3 all squared. Okay, but now I just need to bring back the stuff we found initially. We'll just bring that back and see if we can simplify it and finish it off. So we're gonna bring down 1/3 and our 4 over ln 3. And so I think I'm gonna write this, okay, so we're gonna have 4 ln 3 squared. We're just gonna have our plus 1/3. Then this term, 4 ln 3 minus 6 ln 3 is gonna be a minus 2 over ln 3. I'm gonna check my answer. Okay, so there it is, pretty good problem. Nothing too difficult, but just kind of a lot of steps. So we'll stop it there. Thanks everyone for watching. Have a good day.